Good day everyone, this is Vandana from Department of Computer Applications, SFR College for Women, Sivagasi. Today I am going to teach you on the topic Simplex protocol for a noisy channel in computer networks. And these are the learning objective of this video. First, we are going to learn about the duties of data link layer, then the working of stop and wait protocol, then the purpose of stop and wait protocol for a noisy channel, and then lastly we are going to discuss the algorithm for the stop and wait protocol for a noisy channel. First, we are going to see what is the responsibility of the data link layer. The main duty of data link layer is to take the data bits, that is binary digits, from the physical layer and to form it as frame. Then the frame must be converted into packets and then the packet must be transferred to the network layer. So in this transmission, the main duty of the data link layer is to guarantee the reliable and error-free transmission. So to achieve this responsibility, the data link layer supports a protocol named Simplex stop and wait protocol. Here, the assumption in this protocol is the data is transmitted in only one direction, and the second assumption is no error occur in the data during transmission. So here in this protocol, the main problem is how to prevent the sender from flooding the receiver. That is, if the sender is too fast means and the receiver is too slow means, then there may be the loss of data. So the general solution to this problem is to have the receiver to provide some sort of feedback to the sender. So the process include the receiver should send an acknowledgement frame back to the sender. The purpose of acknowledgement frame is to intimate the sender that I had received the frame sent by you. That acknowledgement also intimates that it acts as a permission to send the next frame from the sender. So this is the process of stop and wait protocol. That is to scrutinize, first the sender will send the frame. For that frame, after receiving, the receiver will send the acknowledgement. After receiving the acknowledgement from the sender, from the receiver, the sender will send the next frame. So this is the working process of simple stop and wait protocol. In the simple stop and wait protocol, our first assumption is error free. But in reality, we can't guarantee that in all ways the network will assure error free transmission. So here, to avoid this, we are going to discuss about Simplex stop and wait protocol for a noisy channel. So in this protocol, our assumption is the channel is not error free. So the frames may be either damaged or lost completely. Also, if there is error in frame means it can be detected by the hardware checksum method. So here our main assumption is the frames may be lost. Also, here one more problem in this protocol is how to avoid the long waiting time for the acknowledgement. So one suggestion suggested by this protocol is to add timer. That is, while a sender sends a frame to receiver, he automatically on a timer. Then the timer will be run. Till the timer changes to 0, the sender must wait for the acknowledgement. If the timer becomes 0 and never the acknowledgement comes means he would resend the frame. So the receiver would send an acknowledgement frame only if the frame is received correctly. So if the frame is in error, the receiver simply ignores it. So the transmitter would time out and would retransmit it. So one fatal flaw with this transmission is that if the acknowledgement frame is lost or damaged, or in case it is duplicate, or in case it is it may be whatever reason it may be, then there is the possibility of the receiving of duplicate frames. So if the frame is duplicate, if the frame is acknowledgement frame is damaged frames, the duplicate frame may be received. So this is the problem of the simplest stop and wait protocol, and we are going to solve it using the noisy channel protocol. So consider a situation. The receiver has just sent the acknowledgement frame to the sender, saying that it received the frame correctly sent by the sender, so it is ready to accept the next frame. However, consider the acknowledgement frame gets lost completely. So the sender timer times out. Automatically the sender will resend the transmitted frame. So here there is no way for the sender to tell whether this frame is a retransmitted frame or a new frame. So the receiver accepts the duplicate frame happily and transfer it to the host. So in this case the protocols fail. So the protocol fails in this aspect. So to overcome this problem, the receiver must distinguish a frame that is seen for the first time or a transmission. So to achieve this, the sender put a sequence number in the header of each frame. So the receiver then checks the sequence number. Whenever he receives a frame, he will first check the sequence number of the arriving frame, and seeing the sequence number itself, he can distinguish whether it is a new frame or a duplicate frame. If it is a new frame, he will accept it. If it is a duplicate frame, he will discard it. So in this case, the receiver needs to distinguish only two possibilities, whether the frame is new or it is duplicate. So for such extent, we need 1-bit sequence number. So 1-bit sequence number is sufficient for it. So at any instant, the receiver accepts a particular sequence number. So if there is any wrong sequence numbered frame arrive on the receiver, then he automatically rejects such frame. If a correctly numbered frame arrives at the receiver, means he will be accepted it. So this is the two example cases. In first case, from the sender, frame 1 is lost while it is sending to the receiver. So the sender automatically resends the frame. For the resend frame, the acknowledgement has been sent to the receiver. So in the second example, sender sends a frame. For that, receiver sends the acknowledgement, but the acknowledgement in intermediate, it has been lost, but it is not intimated to the sender. How it will be intimated? As I already told, it will be guessed by using the timer. So automatically the receiver side timer will be off, that is timed out. So automatically he will send the frame immediately. So once again the same frame will be sent to the receiver. We know already the receiver received the frame, so he will automatically check the sequence number. So sequence number will automatically equal to the last frame received. So the receiver can easily guess that it is a duplicate frame. So he will once again send the acknowledgement, and automatically this process will be correctly formed using the simplest open wait protocol for a noisy channel. So here the positive acknowledgement is called as positive acknowledgement with retransmission, or ARQ, that is automatic repeat request. So these are the protocol definitions we used in this protocol. First, hash define max packet. This determines the packet size for transmission, and then we have a enumeration variable that contains false and true value, and then we contain variable for the sequence number, and then a character array called data. It is used to store the data of the packet, and then we are having enumeration called frame kind. The frame kind contains three possible values, whether the frame is a data frame, or whether the frame is acknowledgement frame, or whether the frame is a negative acknowledgement frame. So for the packet we are going to use the structure. So the structure contains the variables like kind of the frame, sequence number of the frame, acknowledgement of the frame, and then the packet information. So this structure is called the frame. So this frame is framed as the packet, and it will be sent to the network layer by the data link layer. So these definitions are all in the file named protocol.h. And this is the protocol for the sender, protocol from the sender side. And then first in the sender there is a sequence number, and then the frame, and then the packet, and then the event type. For the sender, he will be waiting for the data to arrive from the network layer. So from the network layer, the packet will be arrived from the sender side. So that packet will be converted into frame by the sender. So the frame will be then converted into bits by the sender, and the bit will be transmitted to the receiver by the sender. So here for each transmission, the sender will put the sequence number in order to classify whether it is a new frame or the already sent frame by the receiver. So this is the protocol definitions on behalf of the receiver side. Receiver side, he will receive the data from the physical layer and he will then send the data to the network layer. So from the data physical layer, the receiver will receive the bits, and in the data link layer, the bits will be framed as the will be converted into frames, and from the data link layer, the frames will be converted into packets and it will be sent back to the physical layer. So here too, the main aspect, the main important criteria is sequence number of the packet. So if the sequence number is already exists, means clearly it signifies that it is a duplicate packet, we have to reject it or avoid it. If the sequence number is as we expected, means it is a new packet, so we have to send it to the top layer. So that's all about the Simplex stop and wait protocol for a noisy channel. So the main purpose of the protocol, this protocol is to make the transmission made in the data link layer both reliable and error free. That is, the data link layer should correctly receive the packet from the network layer, and it should be correctly converted into bits, and it should be sent to the physical layer. And on behalf of the receiver side, the bits should be correctly received from the physical layer and it should be converted into packets and it will be correctly sent to the network layer of the receiver side. So for that purpose, we are going to use the Simplex stop and wait protocol for a noisy channel. So thanks for watching. Thanks for watching the video lecture.